Okay, here are the solutions to homework number 6. I'm going to flash through all the answers. You can pause it as you need, check all your answers, and then scroll through the video, and I have explained how to do each problem. So scroll through and look for the ones that you missed and have questions about, and get your questions answered. All right, here we go. I'm going to scroll through them. Okay, and let me give you an explanation for each problem. All right, these first 6 problems, you were supposed to find the slope of the line. So in problem 1, you would find the slope by doing y minus y over x minus x. That turns out to be 1 over negative 1, which simplifies to negative 1. Number 2, same formula. You would calculate the slope by doing y minus y over x minus x. That would be 0 over 8, which simplifies to 0. Number 3, you would calculate the slope by doing y minus y over x minus x. That would be negative 6 over negative 3, which simplifies to 2. Number 4, again, I'm going to use the slope formula, y minus y. That would be this minus this, negative 3 minus 11, over x minus x. That would be negative 7 minus negative 7. That gives me negative 14 over 0, which simplifies to undefined. Number 5, I would find the slope by doing the triangle method. I'd look at this point and make a triangle. And I would use the fact that slope is equal to rise over run. And here, the rise is 1 block. The run is 2 blocks. But this line goes downhill, so it's actually a negative rise. And the slope is negative 1/2. And number 6, the slope again is equal to rise over run. I'm going to make a little triangle using these 2 points and calculate the rise over run. This one, the rise is 1, 2, 3 blocks. The run is 1 block, so the slope is 3 over 1. Which simplifies to 3. All right, here I'm dealing with direct variation. I need to write an equation for direct variation, and I need to find the value of y when x is 7. So I'm going to make a little table and find, let's see, when x is 7, what's y? When x is 7, what's y? xy7, xy7. Okay. All right, to write a direct variation equation, I use y equals k times x, and we know that k is equal to y over x. All right, in number 10, the k value would be 10 over negative 5, or k would equal negative 2. So the equation would be y equals negative 2x. And then when x is 7, y would equal negative 2 times 7, which is negative 14. In number 8, if I want to write an equation, the first thing I need to do is figure out the k value. K is equal to y over x, which would be 22 over 8, which would equal 2 3/4, I suppose. And so You know, I think I'm actually going to make that a fraction. So my equation would be y equals 11/4 x. And then to solve, so that's my direct variation equation. And then to solve for y, I would put 7 in for x. And 11/4 times 7 is equal to 77/4, which is 19 1/4. Number 9. If I want to write the equation, the first thing I need to do is figure out the k value. And the k value is equal to y over x. So this would equal 5/20, which equals 1/4. So my equation would be y equals 1/4 x. And then I can figure out the y value when x is 7 by doing y equals 1/4 times 7. That'd be y equals 7/4 or 1 3/4. And last up, number 10. If I want to write an equation for this, the first thing I need to do is figure out the k value. K would equal y over x. That would equal -1. So my equation here would be y equals -1x. I think a better way to write -1x is just -x. And then to figure out the y value when x is 7, I plug in 7 for x and I get y equals -7. All right, number 11. I want to figure out if the table, if y varies directly with x. So to figure that out, I'm going to check the ratio y over x and see if it's constant. In direct variation, y over x is constant for every ordered pair. So in this case, I have 7.5 over -3. That equals -2.5. I have -2.5 over 1. That equals -2.5. I have -5 over 2. That equals -2.5. And I have -12.5 over 5, which also equals -2.5. So, because y over x is constant, it is a direct variation equation. Yes, y over x is a constant ratio. And so now I'm supposed to write an equation for this table, and I've already found the k value. The k value is -2.5, so the equation would be y equals -2.5x. All the y values are equal to the x value times -2.5. Number 12. First, I need to figure out if y varies directly with x. I can check to see if y varies directly with x by seeing if each y over x ratio is constant. I've got -6 over -1. That equals 6. My next one is 3 over 2. 3 over 2 is 1.5. Okay, those are different. Because those are different, this is not direct variation. Y over x is not constant. And I can move on. All right, here I'm supposed to write an equation. In number 13, I need to write an equation in slope-intercept form. So I need to find the slope find the y-intercept, and write the equation. The slope would equal y minus y over x minus x. Notice I did minus -5 is plus 5. That gives me 1 over -4. And so the slope is -1/4. Next, I need to find the y-intercept. To find the y-intercept, I use y equals mx plus b, and I substitute numbers in. I'm going to put this ordered pair in. So it would be 7 for y, -1/4 for m, -9 for x, plus b. And now I can solve this for b. 7 would equal 9/4 plus b. And if I subtract 9/4 from both sides, 7 minus 9/4, that's 2 1/4, would be 4 3/4. Now I know my slope and I know my y-intercept, so I can write my equation. Y equals -1/4 x plus 4 3/4. Number 14, I need to write an equation in slope-intercept form. So first I need to find the slope, then I need to find the y-intercept. The slope would equal y minus y over x minus x. This would be -14 over -2, which equals 7. Then I need to find the y-intercept. So again, I would use y equals mx plus b, and I would substitute some numbers in. I'm going to substitute this point in. That would be 11 equals 7 times 6 plus b, which would be 11 equals 42 plus b, and I would subtract 42 from both sides and get b equals -31. Now that I know my slope and I know my y-intercept, I can write my equation. Y equals 7x minus 31. Number 15. I need to write an equation for the line. So I need to figure out the slope and the y-intercept, and I can write my equation. The slope I could calculate by using rise over run. All right, slope equals rise over run. The rise is 2, the run is 3, so the slope is 2/3. The y-intercept, I can just look at the graph and see it's right here at 1. The y-intercept is 1. So my equation would be y equals 2/3 x plus 1. Number 16, I need to use the graph to figure out the slope and the y-intercept. Oops. The slope of this line would be equal to the rise over the run. So let's pick this point and this point. That's easy. It looks like the rise is down 1 and the run is over 1, making the slope -1. The y-intercept, I can just look at the line and see where it crosses the y-axis. That'd be right here at -1. So my slope is -1 and my y-intercept is -1. The equation would be y equals -x minus 1. I need to graph each of these. To graph each of these, I'm going to use the slope and the y-intercept. So in number 17, the y-intercept is -3, and the slope is 4, which as a fraction is 4 over 1. So to graph it, I put a dot at -3 on the y-axis, and the slope is telling me to go up 4, right 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And my line would look like that. Number 18, to graph this one, I notice that it's just y equals 2. And I know that since there's no x, it means I have a horizontal line at y equals 2. So I'd go to y equals 2, and I'd make a horizontal line, and I'm done. Number 19 is not in slope-intercept form, so I'm going to have to put it in slope-intercept form to graph it. First, I would distribute the 2 and get y plus 3 equals 2x minus 2. Then I would subtract 3 from both sides and get y equals 2x minus 5. And now I'm ready to graph the line because I know that the y-intercept is -5 and the slope is 2, which as a fraction is 2 over 1. So I would put a dot at the y-intercept, -5. The slope is telling me to go up 2, right 1. So I'd go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And there's my line. Kind of. Number 20 is also not in slope-intercept form, so to graph it, first I'm going to put it in slope-intercept form. I might subtract x from both sides, and then divide everything by 4. This gives me y equals, now 10 divided by 4 is a decimal, but I don't mind the y-intercept being a decimal or a mixed number. The y-intercept is 2 1/2. X divided by 4 is really 1x divided by 4, so that'd be -1/4 x. I now know that the y-intercept is 2 1/2, and the slope is -1/4. So I would start by putting a dot at the y-intercept, 2 1/2. Notice that's halfway between 2 and 3, right? And the slope is telling me to go down 1, right 4. So from here I could go down 1, which is also in between blocks. 1, 2, 3, 4, right 4, and that'd be another point. I could also go the other direction. Instead of going down and to the right, I could go up and to the left. So my line ends up looking like that. All right, last up I have these two rate of change problems. This first one wants me to find the rate of change to the nearest tenth between 11 and 3 p.m. So that would be here and here. So to find the rate of change, you do the same thing we do to find slope. You do y minus y over x minus x. I might do 5267 minus 402 over, okay, so the time's a little tricky. I can't do 3 minus 11. 3 minus 11 doesn't make sense. I could use military time and do 15 minus 11, or I could just recognize that this has been 1, 2, 3, 4 hours have passed, so the bottom's going to be 4. When I subtract the top, I get 4865 over 4, which turns out to be 1,216.3 when I round it to the nearest tenth. And of course, I need units on there, and my units are always the y units per the x units. So in this case, that would be 1,216.3 bacteria per hour. I guess that's how many bacteria are growing per hour on average between 11 and 3 o'clock, right? All right, problem number 22. Problem number 22 is tricky, I think. First of all, I feel like the graph does not give exact values, but I made a table of values for the graph, where x is my time in hours, and y is my temperature. And the ordered pairs I picked were, for this one, I said 1 hour, 35 degrees. That means when the temperature is 35 degrees, it takes 1 hour for it to freeze. When the temperature is 41 degrees, it takes 1.5 hours. I said that point was at 41. I said this point is at 2 hours and a temperature of 52 degrees. I said this point is at 3 hours and a temperature of 77 degrees. And this point is at 4 hours and a temperature of 126 degrees. Now, you might have estimated slightly differently than me, but probably pretty close. And now I'm going to figure out the rate of change from the first hour to the last hour and get the average rate of change for the entire experiment. So again, rate of change is calculated like slope. You would do y minus y over x, 1, 2, 3, 4, 5, I'm sorry, over x minus x. And for that, I got 126 minus 35 is 91 over 4 minus 1 is 3. And then I divided that and got 30.3 repeating. So, if that is correct, then that is telling me, I need units on my answer, and that is telling me that the average rate of change is 30.3 degrees per hour. So each time the hour goes up by 1, the temperature, each time the hour goes up 1, let me say that again. Every time the temperature goes up 30 degrees, it takes 1 more hour for the lemonade to freeze. That is what that would mean. For each 30 degrees the temperature goes up, it takes 1 more hour to freeze. All right? Hope that helps.